back with another NixOS video. This one is number 73, and it's called Building a NixOS Image for Raspberry Pi Part 2. As you can imagine, there was a Part 1. If you haven't seen it, I would probably recommend that you watch that one first. We got our Pi running, and we got HDMI working, and we got wireless working. Instead of downloading an image from the internet, some ISO or something, we built an image using a flake that I modified. I forked someone's repository, modified it such that it will generate a suitable image. And by the way, the talkie script for this video, the thing that you see over on your left-hand side entitled NixOS 73, is available in a link in the description. Where we ended up last time was that got an image burned, booted the Pi. Bob was our uncle, but we weren't quite sure how to update the software that was on the Pi or the configuration of NixOS that was on the Pi. It was contactable on the network, on wireless, and it pushed out stuff to an external display via HDMI, but that's about all it did. So in the first video, I used only a Pi 02W. In the meantime, I've confirmed that the image that we build, which I will build in a moment, will boot on each of a Pi 02W, a Pi 3, and a Pi 4 fine. I haven't tried a Pi 5 because I don't have one. On all those systems, at least wireless and USB, at least via USB keyboard, work on all of those. Yeah, I variously used all those systems to research this video at various points. You should be able to play along with this on any of those, either a Pi 02, a Pi 3, or a Pi 4, or probably a Pi 5 as well. For the record, I still won't be testing GPIO or Bluetooth or Ethernet or sound in this video. This is going to have to wait for another day, just because getting this update stuff working turned out to warrant its own video. So that said, FYI, I did plug an Ethernet cable into the Pi 4 when I had it running, and it got an IP address, so I can't imagine it doesn't work. In the last video, there were a few mysteries that were left unsolved, and a few things that I did less conveniently than is necessary. So we'll talk about those now. In the first video, I couldn't get this Pi 02W to automatically boot. I would have to actually attach a keyboard to it and type boot in order for it to boot to Linux. And I thought it might have just been that particular 2W because it's seen better days. It's had some tough times. But the issue actually turned out to be the orientation. Well, which micro USB slot the power was plugged into versus the keyboard. And so this is the correct orientation where the keyboard should be plugged into the one furthest away from the HDMI interface, and the power should be plugged into the one closer to the HDMI interface. If they are reversed, it works, it boots, but you actually have to type boot for whatever reason. Don't know, but this is the right way to do it. Do it this way. I actually tried this on both my old Pi 0W that's seen better days and a new one, so I know it's not just that old one. It's something about the design of the Pi 02W. So I promised in the last video that I would research building this image without having to use NixOS as the host to build the image, and I did do that. I just booted my Ubuntu virtual machine, and it already had Nix on it. I installed it through the Determinant Systems Nix installer, and it just worked. The instructions that are in part 1 would work on that as well. I did not try Mac OS, nor I've decided will I. It's just just too much to go into at the moment. That being said, updating a Pi remotely, which we're going to see in a bit, using non-NixOS might be a bit of a different story. I haven't verified that all these steps work on non-NixOS. I've been using NixOS to generate the image and to both update the Pi remotely and other stuff. I have not verified that all this works on Ubuntu, and it probably doesn't, because various things we'll talk about in a second. So if you're going to do this, it's probably best to play along with a NixOS host system. So I also was using Balena Etcher to burn the SD card. Became quite inconvenient clicking around to do that, and it's not really necessary. We can just use DD to do that, which I'm going to do in a second. So, by the way, NixOS resizes the root partition of the SD card when it first boots. It doesn't really matter which burner you use to do this. It does that as a matter of course. So I also boosted the system a little, gave it a little bit more RAM headroom by increasing the amount of compressed RAM swap, the ZRAM. This turned out to be particularly helpful on the Pi Zero because it only has 512 megs of RAM. In particular, if you want to run NixOS rebuild on it, it's kind of necessary. You need to do it. So that's already in the configuration of my repository that I will point to in a second. Now we get to today's mystery, which is we have a running Pi, and how do we update it after we get it running? So first thing I'm going to do is I'm going to generate an image. Let's see here. Next build, and this is how we've been generating the image. This shouldn't take too long. Probably speed this up. Oh, and by the way, there's a link in this talkie script over here to this repository where you can check this out. Right, now that we have the image, we're just going to use DD to burn it to my SD card. My SD card is on dev SDB. Okay, it is burned to my SD card. I'm going to remove it. I'm going to jam it into my Pi Zero 2W. And I will show you B-roll of the thing booting. Okay, it appears to be booted. So now that we have it running, it's up, and I think we can ping it. Ping 192.171. SSH to it. Not yet. Takes a little while to generate its SSH host key. All right, we are in. The first thing I'm going to try, and I think this is probably the most practical for most people, because it's just how you manage NixOS on other systems, is to, now that we've burned an image and we have it booted, one of the strange, maybe strange, I don't know, things about it is that it does not, this system does not have it has an Etsy NixOS directory, but there's nothing in it. There's no configuration.nix or hardware configuration.nix. We can solve this. We can fix it. The downside of this approach that I'm going to do is that it doesn't really work optimally on low RAM systems like the Pi 02, like this one. But it does make use of binary caches when it tries to install software, so it's reasonably quick. The thing we want to do is to run sudo NixOS generate config. Centered. And at that point, inside of our NixOS directory, we have configuration.nix, which is mostly boilerplate. Not much interesting in there. But it did generate a hardware configuration.nix for us, which has the devices we need in it to boot. So if we just ran sudo NixOS rebuild switch here, right, now we're crap out. If we just ran that now, it would work, but we'd wind up with a system that didn't have SSH running, and all of our work that we used, all the work that we put into doing configuration inside the 02W file in the repository, where we set up networking and we set up the wireless interface and open SSH, and all that would be lost if we just ran that right now. So we don't want to do that. What we want to do is we want to edit Was I smart enough to leave VI on here? Did I do that? I did. Okay. Basically, we want to keep that hardware configuration thing there. Both of these options we need to keep, but they're already in the 0 to 2W Nix thing, so I'm going to delete them. It's bootloader probe and boot generic X Linux compatible thing. So I'm just going to basically delete everything in this file until the closing curly bracket. And we already have this 20 system state version on there, so we can delete that. Then I'm going to take the stuff that's inside of our NixOS Pi 02 repository checkout, and I'm going to copy most of it. Everything. I'm not going to copy that SD image, import SD image next, but everything from this line down until the closing curly brace, not including it. I'm pasting it here. And these two lines can go. These are only useful for cross-compiling. We're not going to be doing that here. That's all good. We need that. We got to get rid of this SD image stuff. We're not using this to build an SD image, so don't need to do that. We need the firmware, and we need this loader stuff. That's fine. Everything else is not useful. Do I have network? Do I have network twice in there? Yeah, I got to take that out. And this stuff yours is probably going to use DHCP. I've changed mine so that it just uses stack IP address, so I always know what address it's going to be. I don't have to guess at it. Enable SSHD. There's my user information. And for now, I just wanted to install htop. And we'll install that stuff a little bit later. Crap. Okay. Let me, forgot I have to do like W and then name a file. Ooh. Yeah, sweet. Okay. We need to change own some users. Own R. I'll change the owner so that I can edit the files inside of here. And I'm going to remove. I'm going to remove configuration next. And I'm going to move foo to configuration next. Okay, so let's see. Okay. What I've essentially done is I've taken the stuff that was in the 02W Nix file, delta the stuff that was only useful to generate an SD image and cross compile, and I've transplanted it into configuration Nix. So it was really just cut and paste, right? So at this point, our system is configured like any other NixOS system. We should be able to run NixOS rebuild switch. That being said, this is a Pi 0W, and it has only 256 megs of RAM. I have set things up in such a way in the image that we actually have swap space available, and the swap space is not on the SD card; is actually compressed RAM, and this makes it possible. I think this should make it possible to actually run this all the way through. It may crap out in the middle with an out of memory error, but we can just start again if it does. So I'm going to run htop over here so we can see what's happening. And then I'm going to run sudo NixOS rebuild switch -v for verbose so we can see what it's doing. I think that's all we need. Let me make sure that my configuration.nix, it includes the results of the hardware configuration, which is exactly what we want. We can take a look at hardware configuration.nix. Just tells us about the file systems. Basically, the file systems thing is really all the stuff we need in there. I actually want to get rid of, for my purposes, I want to get rid of DHCP. I do not want to use DHCP. Okay. Sudo NixOS rebuild switch verbose. Oh, that's right. Right. Before we do that, before I'm able to successfully run NixOS rebuild switch, I have to update the channel data for Nix. And the way I do that is I do sudo nix channel update. That does take a little bit. It didn't all right, let's try to run NixOS rebuild switch. Okay, so this, that channel update took a couple minutes. It wasn't like the system was under load or anything. It was just doing networking stuff. But now it needs to use the CPU and it needs to use memory to do the loading of all these Nix files, and it takes a surprising amount of memory to run NixOS rebuild. I presume because it's composing this Nix tree. But the nice thing about this is that it shouldn't need to actually build very much software. Only sort of the very local things. It'll grab everything from cache.nixos.org as it does. But you can see, we're bumping up against real memory limitations now. It's actually using some swap and whatever. But it may not finish. It may in the middle. In which case, it's not the end of the world. One of the nice things about Nix is that typically most things are idempotent. So NixOS rebuild does, it does as much work as it can, and it's pretty careful about not saving unfinished work into the Nix store. So it'll do as much as it can, and if it we just run it again, and it'll pick up where it left off. It won't have to redo all that work again. So I will keep this screen up and fast forward it through. All right, looks like it finished. And we did not that's good. Returned most of our memory. Excellent. That's about it for it. Now we just manage it just like any other NixOS machine. We SSH to it. We run NixOS rebuild switch, and after editing our configuration file, it is apt to, on these low memory systems, like if I edit configuration.nix and comment out, uncomment this stuff here, better way to do this. So like installing a bunch of software on here. Let's see how it does. This thing is well and truly struggling. Can't update the HTOP stats. I have it attached to a console here, and it's complaining of hung tasks, and I am impatient. So I'm going to unplug the thing, plug it back in, and start this process again. It will not do the things it already has done, and it probably will finish them. So let's do that. Okay, so let's start again and see if we can finish it. This is the vagaries of having very little memory in NixOS. Or at least using NixOS rebuild switch in order to set up NixOS. Switch. Okay, so it did pick up where it left off and complete it. So you can see the vagaries of trying to use NixOS rebuild on a Pi 02. This would not be the case if you're using a Pi 3 or a Pi 4 or anything with more RAM. So, but at this point, we just manage the system like any other system. We run NixOS rebuild switch, we edit our configuration.nix, run rebuild switch, et cetera, et cetera, et cetera. But obviously for low memory systems, and maybe if you have a bunch of systems that you want to manage, which you probably don't because you're watching this video, right? But if you did, we can use this tool called deploy RS instead of NixOS rebuild switch. And it does approximately the same thing as NixOS. I mean, it has the same effect. It's just that it does more work on a remote system so that the target system, the Pi, doesn't have to do as much work. So deploy RS, Nix and deploy RS are very flexible tools, and there are a number of ways that we can interact with them. At this point, I'm going to abandon, we know that this works. We know that we could do that forever if we wanted to. And we know if we had a Pi 4, we wouldn't have to worry about the memory. But let's say we are worried about the memory and we want our remote system to do most of the work as opposed to the Pi. So deploy RS lets us do that. We could also do this with NixOS rebuild with like a target host flag and a build host flag, things like that. But deploy RS is the way that this repository that I chose to implement the remote building. So I'm gonna keep going with that. So the first way we can use deploy RS on a target is to build all the software locally and then push it over to the Pi. And we do that by cross compiling on the target on the host system. It builds using QEMU, and it doesn't really seem to pull much down from any binary cache at all, so it takes longer, but uses an insignificant amount of memory on the Pi once it's done. And although it takes longer, maybe it's roughly the same amount of time, given that the Pi is slow, and if you have a fast enough system, it might even be faster to do it this way. I tried this in part 1, but what I realized was that I hadn't enabled ARM emulation on my host system. So NixOS, let's see, edit, common, I think it's in common. Yeah. So in NixOS itself, on my host system, this is not the flake that is in the repository I keep pointing you at. This is on my host system in Etsy NixOS. I had to add this emulated systems line here. Without this does not work. It's apparently possible to do this on non-NixOS systems. You can go check out these links if you want to. We don't have to make any changes to the NixOS 02W repository files except to, do the needful about what we need for our domain concerns like projects Pi, NixOS Pi 02. Let's say I want to, this is the stuff we copied over into the configuration.nix, but we're just using configuration.nix and using this as a canonical thing. We have to leave these things in here, these build platform and host platform things. Let's see, let's make it like let's just do rip grep as well here. And then we go in. Now I've already ensured that my host system is willing to emulate an ARM system. So this should just work out of the box. Next run, deploy RS 02W. So what it's actually looking up is this thing in the flake.nix. That's deploy. That's looking up this stuff here. And we're going to point it at 171, which is my Pi. And let it go. My SSH username is Chris M. Right. So it cannot fetch ripgrep from the cache, so it has to build it. And we can see on our system as we do that, we can see that I think it's using QEMU to do that. I don't know if that was using QEMU or not. Okay, so those are the things that it built as dependencies of ripgrep, I guess, or downloaded anyway. We can see that it does most of the work on our host system. If I, let's say h2 that box, and I do htop, you can see that it's not doing very much. It doesn't have much memory used. That deployment was confirmed. Now let's do one more thing, and we'll do btop as well. And we should see that our host system is working kind of hard. It's got stuff going on, but our target system, our Pi, is not doing anything. So that's the difference between these two things. They don't. The Pi is not doing any work when we're using deploy RS in this mode to put stuff on it. That works just as well as the NixOS rebuild stuff does. We will wind up in the configuration that we specified. And by the way, each of these things, when we either run NixOS rebuild on the Pi, or if we run deploy RS on our host system and deploy to the Pi, it creates a generation in the generation list that we can roll back to if we interrupt the boot. If we go to the console and interrupt the boot at boot time, we can roll back to a different generation or use NixOS switch rollback or any of that stuff. That all works. There is another way we can use deploy RS in a different mode, which is we don't need to set up any emulation on our host for this to work. But it's effectively emulating NixOS rebuild on the Pi. It does all the work on the Pi. If we go into our we go into our configuration here and we change this lake.nix. If we turn on this remote build equal true flag there, it will indeed. Okay, our Pi is doing something, so apparently it's deploying. Let's see. What's it doing? Yeah, it did the needful. So, but now that we changed it to use a remote build, we'll see that our Pi, well, I guess I got to change it to actually do something. Let's see, we'll try to install bin tools, why not? And since we're using remote build, we should start to see this, our Pi actually doing stuff after it parses the configuration and figures out what to do. So it's effectively doing the same thing that that NixOS rebuild switch would have done. I think in this case it does use binary cache, so it may be faster under some circumstances, just like NixOS rebuild on the host might be faster because it doesn't have to compile anything. But I don't see much advantage to doing this other than if you're already using deploy RS and you can't get cross compilation to work, then you can use this mode to sort of work around it while you figure it out. All right, so there is a third mode, which I'm not going to go into too much detail about because it didn't work for me. You can tell the Pi to emulate an x86 machine. You can go click on this link for more information. I couldn't make it work. It's supposed to be the best of both worlds because it's supposed to be able to use the cache and build on the host system, but I couldn't make it go. It seg faults for me. So in any case, now I know how to manage my NixOS on a Pi without needing to reflash an image every time I want to change configuration. I'm still not sure what I'd rather use. Did this work? That didn't work. That was the remote build thing. That didn't work. Why didn't it work? I did make it work once. It is not worth the time for me to debug at the moment. It would probably work if I sat here and bored you with 10 minutes of troubleshooting, but I'm not going to do that. So I'm not sure whether I would rather use deploy-rs. Well, I suppose I know the answer for Pi 0W. It's probably better to use deploy-rs, if only to not run out of memory every time you add software. But for Pi 3 or Pi 4 or Pi 5, anything with a gig or more memory, it's probably not worth it unless you're going to manage more than one of them. So anyway, in a follow-up video, I will hopefully ensure that Ethernet, Bluetooth sound, GPIO, and USB storage work, and I will do that on a Pi 4 rather than a 02W. All right. Well, thanks for watching, folks.